Now that we've talked about what is created from basaltic lava flows, we're going to talk about those andesitic lava flows. Andesitic lava flows, they are the intermediate silica composition, right? So in between basaltic and rhyolitic. So they have a higher silica content than basalt, but less than rhyolitic volcanoes. And unlike basalt, they don't flow rapidly, right? They have a higher viscosity. And so they're going to pile up more around the vent. They're going to flow a little more slowly. And because the lava is flowing a little slower, it's going to cool, creating an external crust, and it's going to fracture into rubble that we call blocky lava. This is also what we call lava. And here's a picture of that, right? You can see that as the magma flowed away from the volcano, it cooled into these little fragments, creating a very roughly textured basaltic rock field. All right, andesitic, that's the intermediate amount of silica. Now we're going to talk about rhyolitic. This is the one with the most silica, the highest viscosity, the most resistance to flow. Now, this lava, when it comes out of the volcano, isn't going to want to flow anywhere. It's just going to pile up right in the crater, right in the vent, right in the fissure. And when this happens, it's kind of like making a cork, right? The more and more cooled lava that piles up in that crater, the more pressure is going to form beneath it until that cork explodes. So we get these hugely explosive eruptions of volcanic ash and tephra and all sorts of other debris. All right, so here's a picture of that. Here's that huge eruption. And if you look at the ash underneath the microscope, you'll see that every tiny little grain of ash is actually incredibly sharp. It's like it basically is glass, right? Because it cooled so quickly, you get this glass form. And that's one of the reasons it's so dangerous to be near one of these volcanoes, because when you inhale, you're inhaling little sharp glass shards.